Hello everybody, welcome back. Chris Keating here. We're going to do another 2D kinematics problem. This will be number 5. It's going to be about a sailboat who gets blown by a gust of wind. So let's go ahead and get started. A sailboat is traveling east at 5 meters per second. So he has some initial velocity in this direction, so you have a velocity vector. A sudden gust of wind gives the boat an acceleration, and they give the acceleration here as 0.8 meters per second squared in this direction, 40 degrees north of east. So 40 degrees north the direction it's going. And the question asks, what are the boat's speed and direction 6 seconds later when the gust subsides, when it stops? Alright, so you have a boat, it's going along, constant velocity, then something causes it to accelerate, a gust of wind, so its velocity is going to change, right? So the first thing we need to do is write down the velocity vector. The velocity vector for the boat can be written like this. The component in the x direction, component in the y direction. And the question will be, well, what is the x direction, what is the y direction? Well, I'll call it, since east on a map is usually the x direction anyways, I'll call east the x direction, and north would be the y direction. So minus x would be the west direction, so on and so forth. And so we can go ahead and write that this is just 5 meters per second, and this one happens to be 0 meters per second. It's not moving in the y direction. So that's the velocity vector. And then we're also given the acceleration vector. However, it's not written in component form. It's written in this form where it gives you the magnitude and the direction. So we're going to have to convert it. We want it in the form like this. X component, y component. And the way we do that is with trigonometry, with sines and cosines. So you might have to remember, the saying SOHCAHTOA, yeah. But here it's pretty simple. A sub x is equal to the magnitude of a times the cosine of the angle, and a sub y is equal to the magnitude of a times the sine of the angle, where the angle here was given as 40 degrees. So this angle here is a little less than 45. 45 would be in between. This angle here is 40 degrees, so a little less than in between there. So all you have to do is plug in the magnitude and plug in the angle, and we have the component. So let's go ahead and do that. This is 0.8 meters per second squared. It's given here. And then you multiply that by the cosine of 40 degrees. This is where you're going to need your calculator. I don't have the cosine of 40 degrees memorized. Maybe 0 and 90 degrees I have memorized, and maybe 45 degrees. But very few people have every angle memorized. And you plug this in your calculator and you get an answer, and I'll see what I got. I got 0.61 meters per second squared. Do the same thing for y component. So it's 0.8 meters per second squared times the sine of 40 degrees. You plug that in your calculator, and I got 0.51 meters per second squared. All right, so it has, in the x direction, it has a little more acceleration, and than it does in the the north direction, the y direction. And that makes sense from this arrow here. You can see that this arrow to here is longer than this arrow to here. All right, but the question asks, what's the boat's speed and direction 6 seconds later? So we can find that with our basic kinematics equations. So the change in velocity in the x, we have to break everything into components now because this is two-dimensional, is equal to the acceleration in the x times time. And then we also have that the change in velocity in the y is equal to the acceleration in the y times the change in time. Where the change in time here is the 6 seconds. So we can get the change in velocity by plugging in what we know, the acceleration in the x direction times time. So let's go ahead and do that. It's a 0.61 meters per second squared times 6 seconds. That happens to be equal to, according to my calculations, 3.7 meters per second. You do the same thing for the y. The y component is 0.51 meters per second squared times 6 seconds. And I got 3.1 meters per second. All right, these are the changes. But remember, in the x direction, it already had an initial 5. So we have to add that to this, right? Because the final velocity in the x is equal to the initial plus the change in x, which makes intuitive sense. The velocity in the x direction. So for this one, if we want the final velocity in the x, we have to take that 5 meters per second and then add this 3.7 meters per second to get the total. I'll write it down here. The total velocity is, this is 8.7 meters per second, and we'll box that. That's an answer. And this one in the y, since the initial velocity in the y was 0, this for the y component, this is 0. So the whole change is the final velocity, right? If you had 0 velocity to start out with and then you change by 3.1, then your final velocity is 3.1 in that direction. Okay, we can box that. All right, these are the components. However, they want the speed. So the speed is the total, the magnitude. And so how do you find the magnitude? Well, again, that's trigonometry. It's the Pythagorean, this side squared plus this side squared is equal to the hypotenuse squared, right? So this side squared plus this side squared equals the hypotenuse squared. So if you want the total speed, you take velocity in the x and square it, and velocity in the y and square it, and then take the square root. So you plug this number here into here, and this number here into here. We'll go ahead and do it so you can see it. Square root, something squared plus something squared. I like to make sort of this road map. Then you're going to plug in 0.87 meters per second, and then 3.1 meters per second. And you'll find that you'll get 9.2 meters per second. So this is the magnitude. So that's how fast it's moving after 6 seconds. So we'll box that as an answer. Okay. The other thing is it's asking for the direction. So it asks for the speed and the direction. You get the direction through trig. Also, the angle, the direction is the angle, is equal to the arctan or the inverse tan, same thing, of the velocity in the y over the velocity in the x. So if you want direction, do this. So let's go ahead and plug some numbers in. So velocity in the y was 3.1 meters per second, and then the velocity in the x is 8.7 meters per second. And this happens to be, it's like 19.6 or something. Yeah, we'll just round it up to 20. All right. So its final velocity is 9.2, and its angle now is 20 degrees with velocity vector after the gust of wind. So it's off course a little bit, right? All right, great. I hope you found that helpful. This is a typical problem that you might find, and if you understand this, you understand most of 2D kinematics. Have a great day.